On the culture side, we thought that one of the great exemplars here at Rockefeller is the program that Jeannie Garbarino has developed. Jeannie was an undergraduate in the State University of New York system. She did her PhD at Columbia in nutrition and metabolism, came to Rockefeller for postdoctoral fellowship with Jan Breslow on cholesterol metabolism, and had the then novel idea at Rockefeller that we ought to be developing a science outreach program to try to educate the public more about STEM issues, get people thinking about science in daily life, and what better place to do that in New York City's public schools. And she's developed an amazing program that she will tell you about that brings over 1,700 students and teachers to the Yale campus for hands-on experience in science every year. And we're very proud of this program as well.
Hello, everybody. I'm very pleased to be here talking to you about the work that we do at Rockefeller around science outreach. And I'd love to use this platform to make a case for getting support at all institutions for centralized outreach. Okay, so I want to start off with some educational research information. I love these two quotes. The first is, awe is the emotional state most likely to impact outcomes in science learning, and wonder is the engine of all intellectual inquiry. And I think what we try to do in Rocky2U is really capture the wonder that people can experience through the process of science, and then use that as a hook for them to stay with us. So effective science outreach, one of my arguments is that effective science outreach, you are basically putting a spotlight on the incredible science that people are doing on a daily basis at these institutions, the incredible science that often remains behind closed doors, not for any other reason than people are just busy. But it's important because you need to foster a welcoming environment in order to sustain an inclusive culture. And we know that moving towards mechanisms of inclusivity is really critical right now for the scientific enterprise. But in order to do this effectively, you have to think about science outreach not as a thing you do, but actually as a framework that considers multiple stakeholders and goals. So first and foremost, in order to have effective science outreach, you have to identify who your audience members are. And that includes both the inward stakeholders, who are the people that might be facilitating the engagement activities. And for us, that includes members of the scientific community within Rockefeller. And then you also have to identify your outward audiences. And for us, this is the K through 12 educational community in New York City, which is actually the largest school district in the United States with over 1.1 million students. Secondly, after you've identified who your audiences are, it's important that you are aligning the goals. And so the inward stakeholders and outward stakeholders might have a different set of goals that they want to get out of science or engagement with science. And to be successful, you have to take into consideration what each group wishes from this interaction. Lastly, you have to tailor your strategies. I often think about science outreach the same way I think about scientific research. You have to think about the resources that you have, the people that you have, the time that you have, design things, try it out, fail probably, which is what happens. And then you have to reflect and iterate and try it again, right? So this science outreach is not a one and done. It's something that you're constantly reflecting on and shaping and iterating on, just as you would scientific research. And one thing I want to truly emphasize is that the science outreach framework is people-centered. At Rocky2U, we hold the philosophy, and I think at Rockefeller, we also hold the philosophy that by developing the people who do the science, you will ultimately get really good science coming out of that, right? And so in science outreach, we want to develop the people, both scientists and non-scientists alike, so that we can build this inclusive environment, foster those feelings of wonder, and then encourage people to be persistent in the areas of STEM. And not for the purposes of creating an army of scientists, but being a critical thinker, a scientific thinker is important to engage in a democratic society. And we have seen this example highlighted by the COVID-19 crisis, where we really need people to be thinking about the science in order to make good decisions around how to keep themselves and their families safe. So again, wonder and awe are the hooks, but in order to keep people with you, in order to sustain and encourage persistence, you have to put a lot of work into this. So this is where Rocky2U comes in. So our mission at Rocky2U is to create and support a science outreach framework that brings together the scientific and non-scientific communities so that we can promote a broad appreciation for the process of science and foster a genuine connection between science and our society. And the audiences that we serve primarily are educators. So this includes K through 12 science teachers. These are people in the formal education spaces. We also work to serve science outreach professionals and other types of informal education professionals. We're also very much involved in supporting learners, primarily K through 12, some undergraduates, and a handful of science enthusiasts who come to us to do some tinkering and exploring. And last but not least, we are really, really keen on supporting the scientists behind the outreach. So these are the researchers, professionals, trainees, administrators, anybody who wants to play a role in science outreach. And the guiding principles we have at Rocky2U is first and foremost to promote and support a culture of science outreach. We know that people are coming here or coming to Rockefeller to do research. And we want to make sure that the asks that we're making among the scientific community is aligned with the primary research goals. We don't want to detract from that work. And so we work within the boundaries of what people are capable of doing. Second, we look to foster wonder. You know, this is a word that I'm using over and over here in this talk because I don't want to discredit the critical impact that wonder can have in getting people hooked into science. And we want them to foster that appreciation as an incremental process, not something that when you go up to bat, you're hitting a grand slam, just to use a baseball analogy, every single time. But things are taking place in a really slow way. And there's a lot of failure and iteration. So we really try to promote the value of failure in our work and ensure that people can see that science does not take place in a vacuum and it has relevance to everyday life. Lastly, we are truly focused on social justice in order to provide equitable access and opportunity that are authentic. They reflect science. You know, there's a huge disconnect between what students learn in school and how science is actually conducted. So we want to showcase the amazing experiences that you can have by getting involved in science and making sure that we're always focusing on justice. So we've put together a suite of different programs. This is just a subset of them that are specific for K through 12 students and teachers. And it includes a suite of programs that have multiple entry points. So people can engage with the process of science in a way that works for them, whether it's just attending a science cafe and chit-chatting with a scientist afterwards, or getting mentored research experience. We try to accommodate all sorts of engagement processes. And through this, we see that our New York City students and teachers find that science is interesting and real and fun and meaningful. Our graduate students and postdocs who work with us, so we do engage graduate students and postdocs a lot as volunteers to help run our programs. And through this, we try to make sure that they are meeting their goals of developing important professional skills, you know, learning how to implement effective pedagogies, how to manage their time and projects, and how to engage in inclusive mentorship, and also just to develop their networking and professional opportunities for the future. For our heads of lab or PIs, I think this has been really critical in that they do not need to reinvent the wheel when they're trying to think about broader impacts and other types of, diversity supplements and things like that that are critical for funding proposals. And for the university, this is not just about serving, an outward audience or even just individuals within our university. There is a community impact in that it helps Rockefeller University. I mean, not that Rockefeller really needs to have improved visibility because it's so wonderful and famous, but among the sort of student non-scientific community, it is helpful in improving the visibility. And through the science outreach program, we are centralizing the ways in which we can maximize the strategic impact of our engagement and improve the cohesiveness of our community. And so I want to switch over and talk about how we are turning inward, because if we are to cultivate an environment that embraces the work that we're doing in science outreach, we need to make sure that the people who we are leaning on to have these processes take place are buying into what we're telling them. And so again, here's the sort of definition of our framework, where you have the inward and outward, you think about the goals and you design the strategy. And so just another way of putting it in. So here's where we focus on the inward stakeholders. And what happens over the years of making sure that we are serving the inward stakeholders of Rockefeller University is that when we have events, people show up in droves. This is a representation of one of our science festivals that we hold. It's called Science Saturday. We hold it on an annual basis, and about 200 scientists from the Tri-I community come together to put a bunch of learning stations in place and a full day of engagement with our local community. And this includes administrators, postdocs, graduate students, and heads of lab. And you can see Rick is here too. And Agata is here. We have a ton of people who participate in this all the time. But our work doing this was tested by the COVID-19 pandemic. Once we had to switch to remote formats, it was a little bit of it was a pretty big blow to Rock EDU, because we built a program for the last 10 years where we leaned on in-person events and engagement. And now that we could no longer use these spaces, what were we going to do? And who was going to show up for us? And so, when we were in the before, we leveraged the incredible spaces that we had on campus. We had so much support from everyone on campus, large pools of volunteers, access to a ton of equipment. And that all went away, right? But what we learned, or what we are still learning, is that the online engagement format is providing unique opportunities for us. And it's allowing us to contextualize science and, really reach into people's homes. And that has actually had a really powerful impact on our work. So one example I want to share with you is how we had to shift our summer research program for high school students. This is called the SSRP. And typically we welcome about 40 students into the program, and we match each student with a scientific mentor for 7 weeks that they spend on our campus and do an independent research project in a mentored way. This year, we had already accepted our cohort of students, and we were starting the matching process when the shutdown began. And so we didn't want to disappoint our students. And we knew that there were a lot of programs who were canceling, and we just didn't want to do that. We know students are already struggling with online work. We wanted to make sure that they had the opportunity to pursue science, because we really truly believe in it as a way to engage a more democratic society. So we decided to think about putting together a bunch of research kits for students to do at home. And this is the pictures on the top are just the lab that we have at Rockefeller, the RockEDU lab, the teaching lab, we filled it with supplies and started to just mail kits out. We mailed 63 kits out to students so that they can engage in science from home. And I'm not adding any pictures to this slide because I really want to emphasize that when we asked our scientific community at Rockefeller for help, they showed up. And I was just overwhelmed and moved by how awesome the response was to consider helping us at RockEDU. So the remote SSRP program, because we were not limited by space, as Rick had mentioned, we are a smaller institution. We ended up allowing a larger cohort of students to participate. So we brought in 63 students, and we determined through a bunch of surveys with both scientists and the students and their families that about 20 hours of work was suitable for them as opposed to the normal 40 hours of work, with approximately 4 to 6 hours online, and the rest of work should be done asynchronously. And we wanted to make sure that they understood that science was relevant to everyday life. We wanted to make sure that our students understood that there are multiple ways of knowing, that the empirical frameworks for doing scientific research were not the only frameworks that students could use to uncover information and generate knowledge. And we also wanted to make sure they understood the ethics and social justice and have some fun because they are in high school. And so in addition to that, we asked our scientists to put together who signed up to mentor. They pitched us ideas, and through those ideas, we developed 5 separate research tracks in which we divided our SSRP students into small groups. And we did this to make sure, making sure that our students' resources aligned with the expectations of the research track. So for example, if we did a bioinformatics track, we wanted to make sure that the students had the computing power that was required to actually participate in the program, just as one example. And so these are the themes that actually came up. So we had members of the Greengard and McKinnon labs lead. They took students through a ton of cryo-electron microscopy and database platforms to look at the role of protein folding in Alzheimer's disease. And these are all photos that students have submitted from their homes. We had members of the Cronauer lab help us develop model systems using ants for behavioral research. Cronauer lab members, along with RockEDU, taught students how to go outside, collect their own ants. This is just an example of a housing station for the ants. And they did we built these choice chambers with our fabrication facility and mailed them out to the students so that they could do their own behavioral experiments. We had a ton of fermentation enthusiasts join us to look at the biological and chemical changes during dairy fermentation. And we also worked with Murray's Cheese, which is a very famous cheese store in New York City, to look at some metagenomic data over the course of a year of the aging of a cheddar cheese. So they also got some metagenomic experience through this project as well. The members of the Darnell lab and Rice lab helped us develop a SARS-CoV-2 specific project where they learned about the expression of the virus in infected tissues from patients. And so that was really fun for them. And lastly, all of the yeast people, including myself, this is so my background is in yeast genetics, and this is the track that I led, where you can just simply go outside and grab a leaf or a berry or something like that. And we use the culturing medium of apple juice, which is both safe for students' homes and surprisingly very effective at selecting for yeast species. So this was sort of our really interesting finding through this. And our, we mailed them little baby centrifuges, we had them do DNA extractions, we did some sequencing with them, and they did a bunch of design around growth assays and different types of pressures. So what we found through this was, in our surveys after the program, was that the impact of doing science at home was real. right? Our students believed that they could troubleshoot the experiment when it wasn't going well. And just as an FYI, I made myself available to our students 24/7. I gave them my phone number. I think that's probably not best practice in the before, but I mean, it was the mechanism I had it in the now. And so when they were doing their asynchronous work, I could go online with them and sort of help them troubleshoot, which was really, I think, helpful for them. Our students overwhelmingly believed that they actually participated in the process of science this summer. And a lot of our students are interested in continuing with their experiments after the end of the program. And a couple of the comments that we found, I really like this one. This program let me have more faith in myself and become more familiar with the process of iteration and learning from failure. Working with the limited materials I had at home forced me to think outside of the box and encouraged me to keep trying new methods when my initial results didn't tell me everything I wanted to know. So I think that's really powerful. And because of this, because of the power that we experienced by running these online or remote programs, it inspired us to launch 3 new initiatives that are taking place online. First and foremost, we have the RocketU Fellows program, which is a theory to practice training program for scientists at Rockefeller. And what we're doing with this is having we started in December, and we have 6 scientists coming from the Rockefeller community, and they're joining us on a weekly basis for trainings around cultural competency, theoretical frameworks that include the styles of scientific reasoning and self-determination theory, and thinking about ways to prompt wonder and awe in students to foster persistence and competence in STEM. And so we're really trying to cultivate a superb team of people who can run the SSRP, which will be taking place this summer, again, in remote formats. So we're looking forward to that. My colleague, Dr. Pollard, she set up a Lab Backstage program where she is working with teachers to connect classrooms to informal discussions with scientists across Rockefeller. And so what happens is, this is not a presentation or anything formal, but instead Dr. Pollard will engage scientists for a tour or a demonstration of a tool or experiment, so people can see science as being done by people and as being done through these sort of incremental ways, and to humanize the process altogether. And lastly, my colleague Lizzie is putting together RocketU Biome, and this is going to be a Slack workspace that's dedicated for fostering a community around mentorship. Okay, and I'll end with saying that being at Rockefeller, and I think the work that we're doing alongside the fluidity of the structures, we have no departments, has really allowed us to build community through outreach. And an example of this is when a couple of, I guess it feels like it's 30 years ago by now, but maybe about 2 years ago, I was mailed a flat Stanley, and I sent out a classifieds on our campus listserv, and I said, who wants to participate in this? And I was overwhelmed with how many people were like, come on over and take a picture with us. And I did no work that day, but instead just went around from space to space to space, working with security and custodial and food services, our nursing staff, students, postdocs, carpentry. Here's Allison North in our microscopy core center, Emily Harms, who's our assistant dean. You know, and I think it really showcases that everyone plays a role in science, and all of the support systems that we have at Rockefeller are highly valued. And I never want to lose sight that science requires a lot of people to make it go round. Okay, so thanks for your time. I just want to give credit to my team who are truly fantastic. It's amazing that through 5 people, we can reach thousands of students. And it really goes to show that, just to get into that, you know, capping off my argument, that you can do a lot if you have hard money and a voice, a seat at the table at your institution, and a team of people who are dedicated to the work, you can really, really be effective at science outreach. And I welcome you to get in touch with me at any time. And I also welcome any questions that you might have. So thank you again.
Thank you, Jeannie. What an amazing effort to bring the scientific and education communities together and to promote science outreach. And it's really impressive to see how you guys have adapted your program to tailor the current situation, the constraints imposed by the pandemic. Well, to start the discussion, I'm just going to continue on the adaptation. How easy was it to shift goals? I mean,
it was actually quite difficult. There's no playbook. And so I tried to gather as much data as possible. I surveyed teachers, I surveyed families, students, the scientific community. I talked with the dean's office. So science outreach lives underneath the dean's office to discuss like what is possible. I had a long conversations with, like, for example, our purchasing departments and our lab safety departments. What can I do without getting in trouble, basically? How far can I push it? And so after collecting some data around that, we developed a loose framework, and we sort of threw our hands up and we're like, let's try it and see if it works. And luckily we were able to hit the mark pretty soon. And after a couple of rounds of iteration, I think we hit a stride.
Oh, absolutely. I'll come back to this in a second, but in the meantime, we have a question from a guest, Lisana. Lisana, would you please unmute yourself and ask your question? All right, I'm just going to ask the question on behalf of Lisana, I guess. So Lisana would like to know if I guess folks can join the LAB Backstage and the Rock EDU Slack workspace.
Yeah, so the Lab Backstage program, you can go to our website and folks can sign up for it. If you want to volunteer to give a tour of your lab, or discuss something that's important to you around science, we are always looking for scientists to work with us. We do work primarily within the Rockefeller community because I can call somebody up and say, hey, I need you to do this right now. And people oblige, but that doesn't mean that we can't accommodate people in other institutions. We're more than happy to showcase, because science is collaborative. And that's one of the messages that we want to get out to our students, especially now that it's an international effort and it's highly collaborative. And it's, these lone wolf stories that students are usually shown are really inaccurate. And so we are more than welcome. Please get in touch with me if you want to do this with us. Similarly, the Slack workspace will also be open.
Is it open to public? I mean, how do we get in?
So I can share information. We're launching it next month, and I can share the information on how to join as that is being announced.
Okay, wonderful. So going back to adapting to the COVID situation, looks like 2021 is also going to be virtual, at least a good part of it. So the SSRP is a great example, and some other examples that you've put forward. But I also see that you have a suite of outreach programs. So what other programs do you think you would be able to adapt to the virtual online version?
So we are working to adapt something called the Lab Jumpstart program, which is it's a research skills building program that is aimed at students from minoritized and under-resourced backgrounds. And we are working with the Rock EDU Fellows right now. So we have 2 graduate student facilitators from the Cronauer Lab, Taylor Hart and Lindsay Lopes, and they will be leading social biology curricula for our Lab Jumpstart students to showcase just the process of science. And along the way, we also put these students together. So we will support 16 students. Each, because they are coming from low socioeconomic backgrounds, we provide them with a generous stipend so they don't have to choose between work and pursuing an educational opportunity. We also pair them with advocates, campus advocates. So these are scientists who are pairing up with our students to not around the actual process of scientific research, but instead are there to help them with how to write a formal email, or how to think about college essays, and all these other types of support systems that often get ignored when the goal is to people think that science is, our students often think that you have to sort of only think about science, but we're trying to showcase to them that it's a much bigger enterprise, and developing these other skills is as important.
Accessories.
So I'm really excited about the Lab Jumpstart program. But other programs like our Lab Experience program and Rockety Presents, there's only so much that the 5 of us can do, and we all have little kids. So I'm also trying to be mindful of my team who are often holding a little baby while giving a lecture. So.
Absolutely. That's all right. So Jeannie, once again, thank you for talking to us about your unique program and all your science and outreach endeavor. I really like your quotation, wonder is indeed the engine driving us. And it's very impressive to see how your team has come together to foster wonder and appreciation of science, even in strange times like this. So great job at that. So with that, audience, I guess our live session comes to an end. But then, as always, the discussion can continue in the Slack forum. Please check your chat boxes. You've been invited to a Slack channel where our speakers would join you to answer more questions or to engage in discussions. So please go ahead if you have more questions. From the Life Sciences Across the Globe team, I would like to thank our participants today, Rick Lifton, Michelle Nissen-Swag, and Jeannie Garbanaro. Thanks also to the audience for your participation and for all the lively discussion. Do join us next week as we would be at our institute at UBA CONICET. We would hear about the neuronal basis for collision avoidance. This talk would be from Daniel Tomczyk, who will be joined by Carolina Vera, who would talk about climate changes and opportunities in Argentina. I hope to see you everybody there next week. In the meantime, it's goodbye from Janelia, and stay safe, everyone.